Hey guys, what's up? So I was trying to apply to this job at new grad software engineer backend, and it was really tempting, and I was meeting every requirement of these things. So I came up and filled my application, and I came across this challenge. I spent like a few hours on this, and eventually I solved it, and I was very proud of it. I got rejected and without any feedback, and I feel better about it. So here I am shooting this video on how to solve this problem. First thing is you will visit this link to solve it. So let's go there and see. We see an encoded code that doesn't give us any clue on what we are doing. The first thing you can see is that this is ending in double equal sign, and this code is encoded. So yeah, this is a clue that this is an encoded code you need to decode. From this text, we see that this is ending in double sign, double equal sign. So this means this is a base 64, and we can paste it here and decode. And yeah, this is encoded and plain text. Another thing, if you don't know the type of encoding or the format of the encode, we can say that there is a website that can detect this on its own called the encode. We can paste it here, and yeah, it will detect it. If there was another encoding mechanism was used, so you can detect it here. A third way is that you can ask our good friend ChatGPT and tell it decode this and this the code and wait for it. And it has solved it. So yeah, back to the problem. Let's read the text. Hello, we are glad you are here, blah, 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 blah. And this is a CTF challenge. And yeah, the requirement is there is 4 flags. Each flag is a 7-letter dictionary word. This is a very important clue that we will use in our problems. Let's keep this. There is nothing else important in this text other than this piece of information that this is a 7-letter dictionary word. We can save some time and search for all dictionary words that is containing 7 letters. I came across this one on GitHub. I will link this in the description. But you can do it on your own. You can make your own dictionary and your own code to extract every word. But this is an unneeded effort. So yeah, we can skip and use this word, or you can go with your guts, whatever suits you. Anyhow, so we know that this is a CTF challenge and it contains 7-letter words. Let's get back to the challenge, and well, there's nothing on the text that helps us to solve this. So let's inspect the hidden elements in this Chrome tab. Let's see the hidden HTML. Maybe there is a comment that can help us, and nothing in the comments and nothing in the CSS as well. Let's see network tab. Nothing will help us here anyways. So yeah, there is nothing here. Let's go to the application tab and see any cookies, anything can help us. No, and no, nothing in the cookies and in the local storage. So yeah, we can look elsewhere in the URL and we can see that there is a query taking place in this URL. Select contents from README. So this is the table we are reading this from. We know that this is a single record because of this double brackets, but we can say, yeah, just to be sure, select everything from README. And this is indeed everything in this table. So we are now in a table called README, but we want to know every table in this database. How can we do this? Well, how do we know first the type of this database or the type of language used? So we can say like incorrect query, like select, I don't know, anything. And we get an error that is expected. So SQLite error. We can tell from this piece of information that this is an SQLite database. What can we do with this information? Well, we can query the tables in this database. We know the type already, that is SQLite, so we can say something like select name from SQLite master where type is table. This query will return every table in this database. So let's see. And indeed, we have README, the one we were reading from earlier, and the other one is flags 140. Okay, so this is the other table that we have to read about. or we have to debug. Again, let's just reiterate that this is a query. This is the URL queries. We can pass anything here, and we have already selected everything from README, and we have nothing to do here. So we are going back and querying every table in this database, and we can see that there are only 2 tables. So let's select this one and let's see what's inside of it. So let's say select everything from flags 140. Click enter, and we have 4 records in this table. We are selecting everything, and we have only 4 records. We can also tell from the double brackets that these are the only records in this table. So this looks like URL parameters, or sorry, URL, what do you call it? Subdirectory or whatever. So let's copy it and let's see, how do you use it? So let's copy this, maybe here. I know this is not here because this is AWS and this is subdirectory, so it will be something like this. And let's click enter, and indeed, we are getting somewhere. So we are here going to solve 4 problems, and each problem will give us a flag. You only need 2 to submit in the application here, but we are going to solve 4 of them just for the sake of it. So yeah, let's start with the first one, the browser problem. We go in here and see there is a Python file giving us an error called invalid user agent, and it is expecting a certain user agent to submit with this get request. So if we go to inspect and our network tab here, and let's send another request. Let's refresh the page and let's see browser. Let's go to the headers and let's scroll down, and indeed the user agent is Mozilla 5 and it is expecting this certain one. I'm not aware of a specific method that we can modify the user agent inside of Chrome, but I know we can do this in Postman. So we will go to Postman and paste the link in here. And if we send this request, we will get the same result we are seeing here. But here we are going to modify our headers to match this requirement. So let's go to headers tab and let's add the user agent, and let's paste this certain agent here. I don't think this double colon starts here. So yeah, let's save this and let's send. Indeed, we got our first flag. So let's copy this and paste it somewhere in here. So yeah, this is our first problem solved. Let's go back and let's go to the second one. So we can see the hash problem. Let's do the same thing in here. Let's see. Yeah, we have an MD5 flag plus salt. So this is the MD5 problem, and this is the salt we add to the text before we call the MD5 hash function. So I'm sure you already know this, but you know that hashing is a one-way function that we take a word like this, like a password, and we convert it to some long text like this. Okay, so to increase the security of this, because many people use the same passwords, so we can do reverse engineering and get the real value of the MD5 hash function and yeah, crack the text. So what people use is that we can add a certain salt to this text, or add a certain value to this text before we can call the MD5 function. So what I mean is that before we call MD5 function on the text password, we can do something like, again, the same word, password, but we can insert a certain salt in this text to make it harder to crack. Let's say this one. After that, we will call the MD5 function, something like this, which will result in a very different value from this. So this will be like, I don't know, something like this. This is the point. The point is that you change this text so that you can change the real value of the MD5 function. So what we can see is that this is a flag, okay, and each flag in our problems is a 7-letter word, as we can see from this hint, and we already have our long list of words. So what we are trying to do here is a brute force attack, meaning I take, let's say, this word and let's add it here, and what we can get is the salt value that we have here from the problem. Let's append it here and let's call the MD5 function, and compare the results with this hash value. So if the result of this function call equals this long hash value, then this is a match, and our word will be the one that matches this this text. Okay, so I made a quick script here using PHP. This is the sold value, and this is the hash value that we are going to compare to, and this is the word list that we have downloaded from GitHub. So we will loop into this long text, and each word we will take it and we will add the salt, which is this value here. We will append it to the end of this text, and we will call the md function on the result. We will compare this value from the original value we can see here, and if it is a match, then we will echo out the text or the word that is a match and break. So let's save this and let's call this code. And indeed, this is our second flag. Let's put it somewhere here and let's move on. Let's go to the third problem, which is the exception problem. Save it and let's go. Python is throwing an exception. The exception is starts with an edge. Let's look at this URL and we can see, yes, it is starting with an edge. So let's remove this edge and I don't know, put anything here. And it has raised another exception, which says contains an L, and it indeed has two L's. So let's remove them and let's try again. And too few characters. Okay, let's increase the number of characters. Let's say A. Okay, you need more characters. So let's put another A. And here is another exception, which says does not sum to 42. Okay, so this is a basic math question now. Each word in the alphabet has an index. We want to make this index sums to 42. What I mean is that A is 1, B is 2, C is 3, until we reach 26. And we want, how many words here? 1, 2, 3, 4, 5, 6, 7. We want these 7 letters to equal to sum of 42. So this we can say, like, if Z is 26, let's put like 2 T's. No. Let's say T, and let's say R. This is now 38, 39, 9, 40, 41, 42, 1, 2, 3, 4, 5, 6. I think we need another word. So let's remove this R and replace it with a Q. So this is 41 and this is 42. Again, you can do this with trial and error. This is not a single value that will solve this issue. We can have many words that can have the sum of 42. So let's paste this here and let's see. Indeed, we got our third flag, which is clarify. Let's put it here and move on. The last flag we have to capture is the stream 1. So let's paste this and let's go. We see a single word and there is nothing in the stream or the URL. Let's try to refresh it. We are getting another letter. Let's try again, another letter. Let's try again, another letter, and so on and so on and so on. So let's make this easier. If we copy this link and let's go to the terminal, let's call curl this link. We are getting the same results here, but we want to make this an easier to debug and to analyze. So what I have done here is that I have written a small bash script file that will call this same command 100 times, or even more, even less, whatever, so that I have an easier time debugging this. So let's call the script and let's see. Not this one, sorry. Yes, let's go. And yes, it is giving me what I want. Let's leave it working for some time and I will come back. So the script has finished its call, and let's see. We are getting a stream of letters. We are getting G, L, G, A, E, G, E, and so the first thing you gotta notice is that the letters are repeating itself, and there are multiple letters. Each one is again repeating itself. So let's try and check out the unique letters here in this long calls. So let's open this. We started with a G and we have an L, we have an A, we have an E, we have an I, we have an N, we have, what else? A, G, A, L, N, E, we have a C here. So we have C and C. So yeah, these are the letters G, L, A, E, I, and C. Okay, so these are 1, 2, 3, 4, 5, 6, 7 letters, which indeed is the same as the flag letter size. So this is now a basic dictionary game, which is figure out what word in the dictionary contains 7 letters and contains these exact 7 letters. So what I have done is that I asked Google, find words containing specific letters, and let's see this one, and let's enter these letters, and let's see without these ones. Okay, so these are the results of this stream of letters. I only extracted the unique ones. So let's search, and we have 3 words: angelic and Angelice, I think, and Galenic. Okay, so I think any one of these 3 letters will work. I think angelic is the most common one of these, but I don't think these 2 will give you any trouble. So yeah, that's it. We solved them all. Thank you all for watching, and goodbye.